Hello friends, welcome to my channel. Question number 1.6. 4-point charges QA is equal to 2 microcoulomb, QB is equal to minus 5 microcoulomb, QC is equal to 2 microcoulomb and QD is equal to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of a square? So this is the question. We need to find out the answer. So first we need to know the meaning of the question. What is the meaning of the question? In a square ABCD. So a square will consider as a square. So in this square, what is the name of this square? ABCD. So A, B, C and D. Clear? A, B and C. Okay, sorry. So here is the C and here is the D. Clear? Okay. So in this square ABCD, having side, how much side is 10 centimeter. Side is 10 centimeter. In this square, at the point A, there is a charge 2 microcoulomb. That is plus 2 microcoulomb is placed. At the point B, there is a minus 5 microcoulomb charge is placed. At the point C, there is a 2 microcoulomb charge is placed. Clear? Okay. So I will be rounded this by red. Okay. This here at the point D, minus 5 microcoulomb. Clear? This is minus 5 microcoulomb. Clear? Okay. Then what they told? At the center of this square, there is a charge 1 microcoulomb is placed. In that charge, how much is the force experienced on it? We need to find it. So how to find out the center of the square? Center of the square is the intersecting point of the diagonals. How will you find out the intersecting point? We have to get it. So this is the diagonal AC and this is the diagonal. This is the diagonal BD. So this is the center of this square. So in this we will be placing 1 microcoulomb charge. Okay. Then we need to find out what is the force acting on this charge. What is the sign? Positive charge. We need to find it. So here this point plus 1 microcoulomb is surrounded by 4 charges. So we studied about the superposition principle. Net charge, net force acting on any body, any charge is the vector sum of the force due to individual charges. That means we will find out the force acting on this charge on this charge on this charge on this charge on this separately, and we will find out this vector sum. Then we will get the net force acting on it. Okay. Okay. So here what is the given data? AB is equal to BC equal to DC equal to AD equal to how much? 10 centimeter. And another thing is, if I will consider the intersecting point is O, We know a property is that for a square, the diagonal bisect each other. That means AO is equal to OC is equal to OD equal to OB. Okay, this. No need to find out the value. We can find out this value of OA, OC and OD and OB. But it is not necessary. We will find out. It is not necessary. Okay, so we will find out what is the force acting on this plus 2 microcoulomb on this plus 1 microcoulomb. Okay, so I will consider the force acting on A on O. I will take it as FA. FA is equal to how much we will get based on the Coulomb's force. Coulomb's force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Here the Q1 is 2 microcoulomb. 1 microcoulomb is equal to 10 power minus 6 coulomb and Q2 is equal to 1 microcoulomb. That is 10 power minus 6 microcoulomb divided by the distance between them. That is OA square. Clear? Okay. What is this force? What is the direction of this force? This force direction is, this sign is positive, this sign is positive. So FA is along this direction. So this is the FA direction. So it is a repulsive force. So its direction is along the OC. OC is the direction of this. Clear? Okay. I will take this value is just the magnitude of this. I will consider as F1. Okay. Then I will find out what is the force acting on B. That is, what is the force acting on this B on O. That is, the force acting on B, that is minus 5 microcoulomb on this plus 1 microcoulomb is 1 by 4 pi epsilon naught minus 5 into 10 power minus 6 into 1 into 10 power minus 6 divided by the distance between them. What is the distance between them? OB. So OB square. I will consider this. This magnitude is in F2. What is the direction of this F2? This is negative sign. This is positive sign. So it is an attractive force. It is acting in this direction. Clear? This direction. This is FB. This is FB. Clear? Then next I will find out the force acting on C on O. That means force acting on 2 microcoulomb placed at the C on plus 1 microcoulomb placed at O. That is, I will consider FC. That is equal to 1 by 4 pi epsilon naught 2 into 10 power minus 6 into 1 into 10 power minus 6 divided by OC square. We know OC and OA are equal. So this magnitude is similar to FA magnitude. That is equal to F1. Clear? What is the sign of F1? We will find out what is the direction of this FC. This plus this 2 microcoulomb is positive, this 1 microcoulomb is positive, so this force between them is repulsive. So FC is in this direction. FA and FC are in same direction but opposite sign, so I'll put it as a minus sign here. Okay, what is this minus sign meaning? It is in the opposite direction of FA. Clear? Then next I'll find out what is the force acting on D on O. That is FD is equal to force acting on D on O. That is 1 by 4 pi epsilon naught minus 5 into 10 power minus 6. Minus 5 into 10 power minus 6 into 1 into 10 power minus 6 divided by OD square. OD and OB are equal in magnitude. So this is equal to F2. This magnitude is similar to this. but we need to see the direction of FD. FD is negative, this, and this is this, not FD, this minus 5 microcoulomb, this is plus, so it is an opposite sign, so this is a attractive, so FD is in this direction, this is the FD is in this direction. So we can see that FD and FB are equal in magnitude but opposite in sign, so I'll put a minus sign here. Okay, then now we can find out the net force acting on the plus 1 microcoulomb. So the net force acting on O is equal to what? We'll get it as F1 plus F2 minus F1 minus F2. This is equal to 0. So the net force acting on the 1 microcoulomb is 0. Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.